Okay, we will continue with our review for test 4. And I noticed that on Monday, we did 2 problems too many. So we have only 3 problems to go over from spring 20 and fall 20 that is related to 6.5 and 6.6. Now, so that's what I plan to do first. Like I do spring 20, number 2 and number 6, and fall 20, number 2. And then after that, we will work on fall 19, which when I took a look earlier, it turns out to be all of them is doable at this point. Yeah, all of them are doable at this point. Okay, now, so after I'm done with the first 3 questions I told you earlier, I may give you some time to try to work on these problems here. Okay, the difference is in this fall 19, I did not include in fall 19 in this semester I did not include law of sine, law of cosine, and then what's that, sequence series. I didn't include binomial expansion in test 4. Okay, so we happen to end, their test 4 happens to end at the end of chapter 6. So later on, after I'm done with these 3 problems that I said earlier, I will ask you to do some problems from here before we go over all of them. Okay, now let's go back to this spring 20. Spring 20, we'll do number 2. You will feel that this question number 2 here is actually on the heavy side. It's on the hard part. Okay, let's see. Okay, so evaluate cosine of cosecant inverse 2 and tangent inverse 2. So let's call this A and let's call this B. Okay, so let A be cosecant inverse 2 and B be tangent inverse 2. Both of them in quadrant 1, right? So cosecant A is 2, tangent B is 2. Draw the right triangle correspond to that. Cosecant is reciprocal of sine. So this is 2, this is 1. And tangent B is 2. Means if this is B, this is 2, this is 1. This is then square root of 5. This is square root of 3. Okay, now that question cosine of cosecant inverse 2 plus tangent inverse 2 will then be, because of that substitution, becomes cosine A plus B, which according to our formula, that's cosine A cosine B minus sine A sine B. Okay, now both angles are in quadrant 1, right? Both angles are in quadrant 1. So the value of all trig functions will be positive. So cosine A will be radical 3 over 2 cosine B will be 1 over radical 5 minus sine A is 1/2, sine B is 2 over radical 5. This is radical 3 minus 2 over 2 radical 5. By the way, this is negative, right? Why is it negative? Because radical 3 and 2, which is radical 4, of course, radical 4 is greater, right? So radical 3 minus 2 is negative. Okay. Now, of course, I would like you to rationalize the denominator. We will multiply by radical 5 on the top and the bottom. If I multiply by radical 5 on the top and the bottom, I will get radical 15 minus 2 radical 5. Now, the reason I did not rationalize the denominator right away earlier, because I want to find out first if this is positive or negative. Okay. Yeah. Now, because once I rationalize the denominator, it will not be clear if this is actually positive or negative. So this is square root of 15 minus 2 square root of 5, which is actually square root of 20 over 10. Okay. Now, the thing is, there's a follow-up question. Use the result to determine in which quadrant is these angles located. Okay. Now, A is in quadrant 1, B also in quadrant 1. So, A is between 0 to pi over 2. B is between 0 to pi over 2. Right? When I add, then A plus B will be between 0 to pi, which means A plus B is in either quadrant 1 or quadrant 2. Okay, but that's not enough for us to make decision though. Now, on the other hand, when we look at cosine of A plus B, which is negative, it means A plus B is either in quadrant 2 or quadrant 3. Now, so that A plus B must be in quadrant 2. Okay, that's the argument. How do we know, Thomas, that A is in quadrant 1 and B is also in quadrant 1? Well, because B is a tangent inverse of a positive number. Hold on, but tangent is positive in quadrant 1 and 3. Tangent is positive in quadrant 1 or quadrant 3, right? Okay. Why then you say tangent inverse 2 is in quadrant 1? Well, because by definition, okay, by restricted domain. For tangent to be 1-to-1. Remember that? We restrict that to negative pi over 2 to pi over 2. I'm sorry, without parentheses, without bracket. Now that is quadrant 1 or quadrant -1. It will never give you quadrant 3. Okay, it will not give you quadrant 3. Okay, that's how we know that B is in quadrant 1. Okay. Now that's for number 2 here. Any question? So the first part I think is quite medium level because you need to set it up first. Okay, the nice thing is both of them are in quadrant 1. Okay, so not too heavy with the setup and the computation. But the important part is like, can you argue which quadrant is the sum of these two angles are located? Okay. Now, students who just say, oh, A plus B is in quadrant 2, I don't give them any point. Yeah, I want the argument. Okay, the argument why. And when they say, oh, cosine of A plus B is negative, therefore is in quadrant 2, I give 1 point, but no. Cosine A plus B is negative, maybe in quadrant 2, maybe in quadrant 3. Okay, maybe in quadrant 2, maybe in quadrant 3. It's the A plus B has to be in 1 or 2. Therefore, the intersection either 1 or 2 and 2 or 3. Okay, so from there, then we decide, oh, it must be quadrant 2. Okay, the art of arguing, okay, to support your result. Okay, let's go on to, you know what? Let's go to fall 20 first and do number 2. It's the similar question. Yeah, the similar question. Okay, can I ask you to do this? Okay, let me give you, let's say, around 5 minutes, at least to come up with the value of tangent. Okay, at least to come up with the value for tangent of sum. So yes, let's call this A, let's call this B. Okay, let me give you 7 minutes. So I come back at 9:50. Okay, how is it? Do you need more time? Yeah, I assume you're okay. Let's start. Let A be secant inverse of 4 and B be cosecant inverse of 3. Notice that both of them are in quadrant 1. Okay, the one that we don't have convention for secant cosecant, when we have secant inverse of negative number. Now we don't have that strict convention, but for secant inverse positive, cosecant inverse positive, they must be in quadrant 1. Basically, any inverse trig function, if this is positive here, then it must be in quadrant 1. Of course, there's a limitation on what kind of positive number they are, right? Sine inverse of 2, for example, is undefined, right? Okay, but if they are defined, then it must be in quadrant 1. Now then, let's set up the triangle first. Secant A equals to 4. Therefore, we get this triangle. Secant is the reciprocal of cosine. So this is 4, this is 1, that's square root of 15. Now cosecant B is 3. That's the reciprocal of sine. So this is 3, this is 1, this is square root of 8, 2 square root of 2. So tangent of secant inverse 4 plus cosecant inverse 3, that is equals to tangent A plus B. that is tangent A plus tangent B over 1 minus tangent A tangent B. Tangent A, square root of 15. Tangent B is 1 over 2 radical 2. 1 minus square root of 15 times 1 over 2 square root of 2. Multiply the top and the bottom by the LCD, which is 2 square root of 2. Okay. Then we will get, this is, oops. On the top left, that will be 2 square root of 30 minus 1. And this is 2 square root of 2 minus square root of 15. Right? Now, the thing is this positive or negative? On the top, you can see on the top, that's greater than 1, right? On the top. Actually, no, not about greater than 1. Greater than 0, that's positive. Now, the denominator is actually negative, right? Okay, there are 2 square root of 2, that's square root of 8. Compared to square root of 15, square root of 15 is greater. Okay, so let's say it this way. So on the top, that's positive. The bottom is negative. So this is negative. Okay, later on, we will use that result in the second part. So tangent A plus B is negative. Therefore, A plus B must be either in quadrant 2 or quadrant 4. Okay, for the second part. Now let's rationalize the denominator here. We will multiply by the conjugate 2 square root of 30 minus 1 over 2 square root of 2 minus square root of 15. This is the part I don't like though, to be honest with you. This is the part I say that, oh, it will be quite nasty because of this. On the top left, that will be 4 square root of 60 minus 2 square root of 15 squared times 2. 30 is 15 squared minus 2 radical 2 minus square root of 15. And at the bottom, we have 8 minus 15. This will then be 4 square root of 60. 60 is 4 times 15. So that's 8 square root of 15 minus 30 square root of 2 minus 2 square root of 2 minus square root of 15 over negative 7. So on the top, we will have 7 square root of 15 minus 32 square root of 2 over negative 7. To get rid of the negative, I reverse to subtraction on the top. This should be plus here. Now let me check my computation. I feel something not really right. This should be plus. Sorry, that should be plus. So this should be plus. This should be positive 28. Oh, we can cancel by negative 7, huh? Okay, so there will be negative square root of 15 minus 4 square root of 2. Yeah, remember it should be negative. My computation earlier, if I did not correct that, that means this tangent is positive. Okay, now I corrected already. That's clear that this is negative, right? Tangent is negative. Now, on the other hand, if we go back, remember we said that secant inverse of 4 is in quadrant 1, right? And then cosecant inverse of 3 is also in quadrant 1. Therefore, A is between 0 to pi over 2. The B is between 0 to pi over 2. Such that when we add them, this will be between 0 to pi, which implies A plus B is in quadrant 1 or quadrant 2. Now together with the tangent, A plus B is in quadrant 1. Okay. Now, I would like to do one more similar problem. In fact, let's do exactly the same problem, but this time I changed that to subtraction. Okay, give me a second. Give me a second. Let me screenshot this. Let me screenshot this. And then do that on the extension. Let's do that. Let's do that here. I wonder if I can put it here. No, I cannot. Oh, okay, downstairs here then. However, I changed the question. I changed the question. Okay, I changed the question. Make it minus instead. Make it minus. Make it minus. Okay, make it minus. So let's see what will happen. Let's see what will happen. Fast forward. Fast forward. This is our A. The situation is 4 over 1. So this is square root of 15. This is for B. This is 3, 1. This is 2 square root of 2. Okay. Now it's actually about the second part. If A is in quadrant 1, which implies A between 0 to pi over 2, and B also in quadrant 1, which means B also between 0 to pi over 2, then what happens if you subtract them? Have you ever think about it? What happens if you subtract? Now, the logic will be as the following. Then what is the maximum for A minus B? The maximum for A minus B will be the maximum of A minus the minimum of B. Now, think about it. To get the maximum of a subtraction, right? To get the maximum of the subtraction, you maximize the A. Yes, yet you minimize the B. Okay, such that the maximum of A, which is pi over 2, minus the minimum of B is 0, that's pi over 2 at most. On the other hand, the minimum will be when you minimize the A and maximize the B. Okay, that will be negative pi over 2. Okay, so this comes from pi over 2 minus 0. This pi over 2 minus 0. Okay, while this one here, to get the minimum here, we get you minimize the A, you maximize the B. Does it make sense for you? Okay, so this way, then we see A minus B will be either in quadrant 1 or quadrant -1. Okay, you can also say quadrant 4 in the name of coterminal angle. Okay, now let's see how about tangent A minus B, tangent secant inverse of 4 minus cosecant inverse of 3. This will be tangent A minus B, which is tangent A minus tangent B over 1 plus tangent A tangent B. Okay, this is radical 15 minus 1 over 2 radical 2 big over 1 plus radical 15 times 1 over 2 radical 2. Multiply the top and the bottom by 2 radical 2. Let me multiply by 2 radical 2. That will give me 2 square root of 30 plus 1, I'm sorry, minus 1 over, hold on. Did I use minus earlier on the top? Why I feel like something not right? Did I use minus? It should be plus, duh. See, I suddenly changed. Good thing I did that this problem again. You see, I suddenly changed from positive becomes negative. Duh. Oh, I need to fix this. I need to fix this. I need to fix this. So this will all be positive. Uh-oh. Uh-oh, this is not nice. I need to correct that again. So this is 9 square root of 15 plus 32 square root of 2 over negative 7, which is negative of 9 square root of 15 plus 32 square root of 2 over 7. It is still positive. So the second part, the solution for the second part is still the same. Okay, I'm sorry. Later on, you know that I will what's that? I will give you the PDF, okay? So you can fix it. So this is 2 square root of 2 plus square root of 15. Both of them positive, right? Both of them positive. The top one we know is positive. The bottom one is all clearly positive. So that's greater than 0. Okay, so you can simplify this yourself, okay? But my focus will be here. My focus will be here. Since tangent of A minus B is positive, then A minus B must be either in quadrant 1 or quadrant 3. So from 2 point of view, A minus B must be in quadrant 1. Okay, just to show you what happened if we subtract. my key part that I want to emphasize here is how to get this. What happens if you subtract? When you add, the lower bound will be the sum of this. The upper bound will be the sum of this when you add. But when you subtract, then the upper bound will be the difference of this. The lower bound is the difference of this. Okay. Now think about it though. It's actually common sense. It's not something like you never seen before. Okay. Yeah. Just extra notes. So those students who don't watch this lesson here, they don't really have a systematic way to answer this question. Suppose I give you A is any number between -5 to 7, and B is any number between 2 to 15, let's say. Now, then what is the maximum value for the sum? The maximum value will be 22. The minimum will be -3. Right? Okay. What happens if you subtract? When we subtract A minus B, then the maximum will be 7 minus 2, that's 5. The minimum will be -5 minus 15, that's -20. Now, there was an SAT question like the following. This is SAT question. Out of topic. This is out of topic, but I hope it gives you some idea. Now, suppose we have a set X, which is integers from 1, 2, 3, 4, and then Y integers, let's say -5, -4, -3. Okay, now, and then the question was, find the set of all possible outcomes when you add any elements from X with any element of Y. So what are the possible outcomes? What are the possible outcomes? You see, if I add 1 with -5, the minimum, that will be -4, right? Okay, now when I add 1 with -4, 1 with -3, there will be -4, -3, -2. And then if you do this, you will end up with consecutive integers. Does it make sense? You will end up with consecutive integers. Now, the thing is, it will add up to what? The answer is it will add up to 1. There's no way you get more than 1. The only way you can get 1, the sum of 1, is when you add 4 and -3, right? Okay, so that's the maximum possible. The minimum possible is -4. Okay, so the possible outcomes are -4, -3, -2, -1, 0, 1. Does it make sense? Okay, now, the actual question in that SAT was the following. That X is the set of, let's say, -10 all the way to 20. And then Y will be from, let's say, 7 to 100. And the question was, how many elements in X and Y? Number of elements in the set X and Y. Now, if you add, the minimum is -3, the maximum is 120. Now, how many elements there? No, not 120. It's 124. The answer is 124. Okay. But Thomas, 120 minus negative 3 is 123. That's right. There are 123 elements after negative 3. But if you include negative 3, that will be 124. Okay. You don't believe me? Try it. I'm teaching you logic here. I'm teaching you logic here. Sometimes these logic are too simple, and you do it different ways, you get different answer. Okay, so let's say you have boxes. Box number 1, box number 2, box number 3, box number 4, box number 5. How many boxes there? If you say 4, you know your eyes must be something wrong with your eyes. Right? Box number 1, 2, 3, 4, 5. So there are 5 boxes there, right? But when you subtract 5 minus 1, you get 4, not 5. So what is the answer? Do you have 5 boxes or 4 boxes? Yeah, clearly you have 5 boxes, right? So what this 4 represent? This 4 represent the number of boxes after box number 1. That's what 4 represent. Okay, but if you want to include that one, then there are 5 boxes. Okay, now this actually has some other SAT question, another SAT question related to that. Okay, the question was this. I remember this question very well. On a block, on the street, one block of a street, you see a house number 500 and even number on that block. Okay, even number. So 500, 502, 504, all the way to a house number 600. The question was, how many houses on that block? On this row here, how many houses? And a lot of students actually say, oh, there must be 100. They must. So one of the option is 100. You know it's not. Okay. No, it's not. It's even number. So it won't be 100 houses. Okay. Now somebody say 50. Why? Because there are 100 houses, but you only get even numbers. That's also wrong. The answer is 51. Okay. The difference is 100 divided by 2 means there are 50 houses after house number 500. So there are 50 houses here. You have 50 houses here. If you include house number 500, then there must be 51 houses. Okay. Now, plenty of students, including the one that I prepared before, around 15 years ago, I taught SAT. Okay. And that's how I found out, wow, the questions are quite easy. Okay. The questions are actually quite easy. But why plenty of students didn't do well in SAT? Because it's multiple choice. Okay, you think multiple choice are easy questions? No. Yes, the answer is in front of you, so it's multiple choice, right? So you just need to find out what is the right answer. But because we tend to react really fast, okay, it's not about the questions, it's about our mentality. We have that instant noodle mentality. We want to get the answer fast. Okay, so we don't even put a lot of thought into that. We react faster than our brain. And that's where a lot of students actually missed it. Okay. When they see easy questions like this, they react too fast. When they see hard question, they give up. Those are the type of mentality I have when I prepare SAT around 15, 17 years ago. Now, the sad thing is current students, fresh graduate from LAUSDs, I heard is even worse. You know, they did much less during their high school, such that when they go to college, they have very hard time to adjust. Okay, please don't have that. Okay, use your brain. Okay, use your brain. You have it, use it. Okay, you have it, so use it. And the questions are designed with the assumption that you have brain to think, to use. Okay, giving you problems that you don't need to use your brain is actually offensive, supposed to be. Okay, but strangely, some students don't find it offensive when you get easy questions instead. My middle school instructor, I learned trigonometry in middle school, and yeah, we with you learn trigonometry with me only for like 3 weeks, maybe 2 weeks, 3 weeks. Yeah, let's say 3 weeks, right? Okay, we learn trigonometry for at least 1 month. Okay, so I'm not saying that, oh, in high school we are so good. No, it's not about that. Okay, we actually took more time to do that. Okay, that's why we can absorb better, because we have more time to sink in and more exercise to do. Now you are more mature, age-wise, so the assumption is you can absorb even faster. Okay, but my instructor, the one I said that usually the one who taught me how to teach, she was the one telling me, said, you know what, there are times I feel that you guys, we as students, are the one wasting her time. It's like she taught so deeply, so thoroughly, but we didn't really follow her, not because we don't want to, no, not because we didn't understand, but we just keep on playing. Come on, it's middle school students, right? Okay, but she also said, but there are times I feel like I just waste your time. Like asking you Mickey Mouse question that I know you must know is a waste of time. Okay, and that's actually offensive uh, from student point of view. Okay, if you want to ask me easy question, okay, like you know that I know it, what for? Okay, you should ask me a question that really asking me, do I know that question, the answer for that question or not? Okay, so that's her logic. Okay, if I ask you a question that I know for sure that you know, that's actually not a question. Okay, should I ask you 1 plus 2 in your test? Okay, and of course, because I give you that question, I have to grade it, right? But I know everybody must know that. Okay, you even have calculator to do this, right? Okay, so Thomas, why don't you ask this question? Well, because it is offensive. Okay, first, you are in pre-calculus class. We don't ask that question. Okay, second, do you pass a student who knows how to do this pre-calculus class? Come on, no, right? Okay. Yeah, I'm saying this because you need to build that sense of being offended for getting a Mickey Mouse question. Okay. Well, anyway, number six from this spring 20, the last question that I will do before we go to fall 19 question. Sine 5x minus sine 3x equals to sine x. Solve that for all x in degree. And the hint is use sum to product formula first. Now, in your test later on, I don't think I will give this hint anymore. Okay, this hint is basically a give out to this question. Now, to my surprise, however, even until last semester, so 2 semesters ago, and last semester in fall, when I asked this type of question, you know, we did this question on Monday, right? Let's see. We did it here. Okay. Even until last semester, half of the class who were left during in test 4 didn't know what to do. They just leave it blank. The formula was there, and that was an open book. Okay, the formula is at the back, right? Do you see that? Is that here? The formula is here, but they don't even know that they have this formula at the back of their test. Okay, and even if they know, they don't know how to use it. Don't you think it's kind of like, what? Okay, so yes, you need to study. Okay, you need to study and practice. Now, sine minus sine is what? Sine minus sine is 2 solution. Sine minus sine is 2 cosine sum over 2 sine difference over 2 equals to sine x. Okay, so x plus y, that becomes 5x plus 3x. This is 5x minus 3x. Okay, so this is 2 cosine 4x sine x equals to sine x. So the first step is really just applying that sum to product formula. You need to know which one to apply though. Now, then the next step, common mistake, dividing by sine x. No, you cannot. Unless you identify, if you really want to divide by sine x, okay, so you say 2 cosine 4x equals to 1, right? You need to identify right away, or sine x equals to 0. You see what I mean? Okay. If you write it that way, I will accept, even though I don't like it. Okay, why? Because we are not supposed to divide by an expression that is possibly 0. Okay, okay. And if you anticipate that, I don't mind. Okay, but most students, they don't think that way. They don't think that way. They don't think that way. It's the same question with this though. It's like when x squared equals to 2x, what is x? A lot of them say, oh, divide by x, so x equals to 2. But clearly, by just looking at that, when x equals to 0, it's okay, right? But because they divide by x, they miss that solution that is like very obvious in front of them. Okay, the proper way is subtract by sine x and factor. So you see that sine x equals to 0, right? Or cosine 4x equals to 1/2. Now sine x equals to 0 when x is in degrees, then there will be 180 degrees K. 0, 180, 360, and so on and so forth. Now cosine 4x equals to 1/2 means 4x is 60 degree or 360 degrees K. Or cosine also 1/2 when the angle is 300 degrees. Okay, now divide by 4. So x equals to 15 plus 90 degrees K, or 75 degrees plus 90 degrees K. Okay, for K equals to, for K, an integer. Okay, that's how we do it. Now, let's go to 419. Let's go to 419. Solution. In 419, the setup was a bit different. The setup was a bit different. Now, in spring 19 and fall 20, we already remote. Okay, so I allow them open book. In fall 19, it's not open book. Okay, it's not open. That's in class. That's the setting. Okay, that's the setting. So the type of question I ask tends to be a bit more, supposed to be a bit easier. Okay, knowing that you don't have textbook to refer to. Okay. Number 1A, find the exact value of tangent 165. Now try to think how to build this 165 using special angles. I can think of 120 degrees plus 45 degrees. Or you can also use 135 degrees plus 30 degrees. Okay, either one. Either one. Let me use the first one. So tangent A plus B is tangent A plus tangent B over 1 minus tangent A times tangent B. Now tangent 120 degrees, the reference angle 60 degrees in quadrant 2, that's negative radical 3, plus tangent 45 degrees 1 minus negative radical 3 times 1, negative radical 3 plus 1 over 1 plus radical 3 multiplied by the conjugate. I'm sorry, conjugate of the denominator. 1 minus radical 3, 1 minus radical 3. Then I get on the top, I will get positive 3 minus 2 radical 3 plus 1 over 1 minus 3. That's 4 minus 2 radical 3 over negative 2. That's negative 2 plus radical 3. How about sine 19 pi over 12? How do we break it up? That's sine, what will that be? What will be the good one? 9 plus 10, right? 10 pi over 12 plus 9 pi over 12. That's one way. It doesn't have to be addition though. It doesn't have to be addition. Yeah, it doesn't have to be addition. Let me see. We can also use 21 minus 2. Yeah, 21 pi over 12 minus 2 pi over 12. Now 21 pi over 12 reduced by 3, that's 7 pi over 4 minus pi over 6. The nice thing about this is pi over 6 is in quadrant 1. Okay, so 10 pi over 12 plus 9 pi over 12 is not the only way to get, 19 pi over 12. But let me use that one. Yeah, but let me use the first one. This is sine 5 pi over 6 plus 3 pi over 4, which is sine 5 pi over 6 cosine 3 pi over 4 minus cosine 5 pi over 6 sine 3 pi over 4. Sine 5 pi over 6, that's quadrant 2. Sine is positive. Reference angle pi over 6, this is 1/2. Cosine 3 pi over 4, that's negative radical 2 over 2. Cosine is negative in quadrant 2, minus cosine quadrant 2, that's negative radical 3 over 2. And sine 3 pi over 2 is radical 2 over 2. So this is radical 2 plus radical 6 over 4. Not supposed to though. Give me a second. Something not right. Something not right. Yeah, something not right here. So this should be plus here, right? Sine is sine cos plus cosine, and then this is negative. So this is negative here. That's negative here. Okay, because sine in quadrant 4, this is in quadrant 4. The sine in quadrant 4 should be negative. Right? Should be negative. You can see that clearly if you factor the negative out here. If you factor the negative out, then you get square root of 2 plus square root of 6 over 4 with the negative right in front of the fraction. Okay. Now, how about cosine 195 degrees? This is cosine, this is quadrant 3, 15 degrees after 180. So let me use 135 degrees plus 60 degrees, or you can also use cosine 150 degrees plus 45 degrees. Like either one. Okay, cosine 135 degrees, cosine 60 degrees minus sine 135 degrees, sine 60 degrees. This is negative radical 2 over 2 times 1/2 minus radical 2 over 2 times radical 3 over 2. So that's negative radical 2 minus radical 6 over 4. If I factor the negative, oh, do you notice that it's the same answer to part B? So if we convert this to degrees, this is 285 degrees. Is sine 285 degrees, is it equal to cosine 195 degrees? Is it true? Okay, just out of curiosity, how do we show that these two numbers supposed to be equal? Look at the reference angle. Sine 285 degrees is equal to negative, it's quadrant 4, right? It's equal to negative sine 15 degrees. Okay? Which is equal to negative cosine 75 degrees. Are you right? No. The reference angle here is 75, not 15. 75. This is 15. Now, on the other hand, cosine 195 degrees, that's quadrant 3, that's negative cosine. Reference angle is 15 degrees. So they're supposed to be the same. Number 2, use half angle to find cosine 112.5. Half angle. So cosine 112.5 degrees is equals to cosine of 225 degrees over 2. Now, 112.5 degrees is in quadrant 2, so it is negative. Cosine is negative, square root of 1 plus cosine 225 degrees over 2. This is negative square root of 1 plus square root of 2 over 2, big over 2 inside the square root, which is negative square root of 2 plus square root of 2 over 4, which then becomes negative square root of 2 plus square root of 2 over 2. Okay, because we know it's in quadrant 2, cosine is negative. Number 3. Write sine 3x in terms of sine x or its power. We did this problem before, but I wonder if you can replicate that. Together with your break, I would like you to replicate that. Sine 3x is equals to sine 2x plus x. Then you expand it. Okay, that should take you around 3 more minutes from there. Okay, around 3 more minutes from there. Let me ask you to do it. And also try to do number 4 to prove that. You will prove that from left to right. So number 3 should take you 3 minutes. Number 4 should take you 6 minutes. Let's say 10 minutes plus another 10 minutes. We come back at 11 o'clock. Okay, 11 o'clock, you are done with number 3 and number 4. So this is sine 2x cosine x plus cosine 2x sine x. This is 2 sine x cosine x times another cosine x, right? Okay, remember I marked it this way last time? Okay, and then later on for this guy, I will substitute to be plus 1 minus 2 sine squared x. There are 3 variations for cosine 2x. Now I use the third variation because we need to express everything in terms of sine x, right? Now then the first term becomes 2 sine x cosine squared x plus sine x minus 2 sine cube x. That is 2 sine x times 1 minus sine squared x plus sine x minus 2 sine cube x. That will be 2 sine x minus 2 sine cube x plus sine x minus 2 sine cube x. That is 3 sine x minus 4 sine cube x. Okay, that's for number 3. Let's see number 4. Proof this is equals to that. So I will go from left to right. Now you may wonder, Thomas, why don't I go from right to left instead? The way I think is this. I can expand this guy. Okay, that will give me 2 terms, right? And that's exactly the same two terms I have there. So very likely from left to right will be the easiest one. Okay, now I'm not saying that doing it from right to left will be wrong. No, it could be, but the one quite obvious for me right now is from left to right. Okay, and this will be on the top. I will have sine A cosine cosine B minus cosine B sine A. Now separate these two terms. I think I write it wrong here. So cosine A sine B. Yeah, because otherwise it becomes 1 minus 1. So this is cosine A sine B sine A cosine B. Now the first term becomes 1. The second term becomes cotangent A tangent A, which is our right hand side. Okay. That's for number 4. Let's go on. Oh, this one here, long time no see. I really want you to do this one on your own. Should I ask you to do this or should I just do it? I just do it. Yeah, because I want to finish the whole test today for this one. Okay. So let's see. So tangent A equals to 3A is in quadrant 3. Now let's take a look on the reference angle. Tangent A hat equals to 3. So if this is A hat 3, 1, this will be square root of 10. So sine A hat is 3 over radical 10. In quadrant 3, sine is negative. So sine A is negative 3 over square root of 10. Cosine, if in quadrant 3, it's negative 1 over square root of 10. Okay, so I look at the reference angle first and then see what happened with sine cosine in quadrant 3. Now secant B is equals to 4, but because it is in quadrant 4, let me look at the reference angle. Secant, so this is 1, this is square root of 15, right? So sine B hat in quadrant 4 is negative, hold on, sine B hat, that's a acute angle, so that's square root of 15 over 4, but sine B with B in quadrant 4 will be negative. Cosine will be just the reciprocal of secant. The tangent will be negative then. Okay, let's see. Part A. What is sine A minus B? That's sine A cosine B minus cosine A sine B. It's negative 3 over radical 10. Cosine B is 1/4 minus cosine A is negative 1 over radical 10. Sine B is negative radical 15 over 4. This is negative 3 minus radical 15 over 4 square root of 10. This is clearly negative, right? That's clearly negative. You can factor the negative out to see that better, right? Let me do that. Okay, in fact, I can, this is a plus. I can simplify a bit further. 150 is 25 times 6. How about cosine A plus B? That's cosine A, cosine B, plus sine A, sine B. This is cosine A is negative 1 over radical 10. Cosine B is 1/4 plus sine A is negative 3 over square root of 10. Sine B is negative square root of 15 over 4. That's negative 1 plus 3 square root of 15 over 4 square root of 10. Now, this is clearly positive, right? This is positive. If I rationalize the denominator, that will be 40 here, multiplied by square root of 10, multiplied by square root of 10. Okay, this is clearly positive. Now, why do I want to know the positive, negative? Well, because then from there we can say which quadrant it is located, right? Sine A minus B is negative, but cosine A minus B is positive. So from there, we know A minus B must be in quadrant 4. Okay, you can also say quadrant -1 if you want. How about sine 2b? Sine 2b is 2 sine b cosine b. Sine b is negative radical 5 over 4, negative radical 15 over 4, and cosine b is 1/4. So this is negative 2 square root of 15 over 16. That's easy. How about tangent 2b? Tangent 2b is 2 tangent b over 1 minus tangent squared b. That's 2 times negative square root of 15 over 1 minus negative square root of 15 squared. That's negative 2 square root of 15 over 1 minus 15. Negative 14 at the bottom. Oh, we can reduce, even cancel the negative square root of 15 over 7, which is positive. So sine 2b is negative. Sine 2b is negative, but tangent 2b is positive. So angle 2b must be in quadrant 3. Which quadrant is angle alpha A over 2 located? Angle A is in quadrant what? Angle A is in quadrant 3. So that A must be between pi to 3 pi over 2. Or you can also use degrees if you like. Okay, now then, when we divide by 2, then it is between 90 degrees and 3 pi over 4, which is less than pi, right? You see, for quadrant 2, it is between pi over 2 to pi, okay? So, our a over 2 must be in quadrant 2. Now then, how about cosine of a over 2? Well, because a over 2 is in quadrant 2, cosine is negative square root of 1 plus cosine a over 2. What is cosine a again? Negative 1 over radical 10. Negative 1 over radical 10. Oh, this will be quite nasty, huh? So multiply by radical 10 on the top and the bottom. That will give me radical 10 minus 1 over 2 square root of 10. Multiply by radical 10 on the top and the bottom just to rationalize that. That will give me negative square root of 10 minus radical 10 over 20. Multiply by 5 over 5 on the top and the bottom. That way, then I get negative square root of 50 minus 5 radical 10 over 100. Then I can take that 100 out. 50 minus 5 square root of 10 over 10. But this 10 is already outside of the radical. Okay, that's for part G. Number 6, find the exact value in radian. Remember, even though this was with calculator, but not open book. Okay, cosine inverse of -1. What's that? Cosine what is -1? It's pi. Okay, or you can also do it. This is equals to pi minus cosine inverse of 1, which is pi minus 0, which is pi. Okay, this is equals to negative tangent inverse of radical 3, that is negative pi over 3. Tangent inverse of tangent 150 degrees. This is tangent inverse of tangent 150. That's quadrant 2. So tangent is negative, reference angle 30 degrees. This is tangent inverse of, you know what? Let me do it this way. Let me pull tangent inverse of negative is negative tangent inverse of positive. Now, because 30 degrees is in the restricted domain for tangent, then this is negative 30 degrees. But we need that in radian. Okay, you know what? Let me do it this way. Let me do it this way. Okay, now another alternative from here, I go on. Another alternative, I compute what is tangent 30 degrees. Tangent 30 degrees 1 over radical 3. Okay, so this is negative tangent inverse of 1 over radical 3. That is negative pi over 6. Okay, part D. What is sine inverse of cosine 5 pi over 3? Cosine in quadrant 4 is positive. The reference angle is pi over 3. Cosine pi over 3 is 1/2. Sine inverse of 1/2 is pi over 6. That's for number 6. Let's go on to number 7. Sine of half angle equals to sine t. I will do this. Let theta equals to 0.5 t. Otherwise, I need to use I need to square both sides, right? Because sine half t, sine t over 2 is plus minus square root of 1 minus cosine t over 2. Okay, now instead of doing that, I do double angle. Okay, so the equation becomes sine theta equals to sine 2 theta. So 2 sine theta cosine theta minus sine theta, factor the sine theta. So either sine theta equals to 0 or cosine theta equals to 1/2. Notice that I don't square both sides, right? So I'm safe, actually, I'm safe for this. This will then be sine theta equals to 0 means theta equals to, in radian, 0 plus pi k. But that is t over 2 though. So t will be 2 pi k. Cosine theta equals to 1/2 when theta equals to pi over 3 plus 2 pi k, or 5 pi over 3 plus 2 pi k. But then that is t over 2 for the theta. So the t will be 2 pi over 3 plus 4 pi k, 10 pi over 3 plus 4 pi k. Now do not change that 10 pi over 3 becomes, even though they are coterminal, do not make it 4 pi over 3. No, it's not. No, it's not. Okay, because the period is not 2 pi k right now. It's not 2 pi. The period right now is 4 pi. Okay, so these are the answer. Yeah, I will do it this way. I will do it this way. Number 8. What is cosine of this to be negative 1/2? This is negative 1/2, right? I hope you realize that. Okay, which means 3 theta minus 40 degrees is equal to negative in quadrant 2 and quadrant 3. In quadrant 2, that's 2 pi, oh, I'm sorry, in degrees, so that's 120 degrees. Plus 360 degree K. 3 theta minus 40 degrees is quadrant 3, that will be 60 degree plus 180, 240 degrees plus 360 degree K. So let me solve this. 3 theta equals to 160 degrees plus 360 degrees K divided by 3. That's for number 8. Now, I have seen people try to mess it up so badly, they make it into cosine 3 theta cosine 40 degrees plus sine 3 theta sine 40 degrees equals to negative 0.5. You go nowhere if you do this. In fact, imagine in your next test, I ask you this question instead. And I expect your next step should be this. Does that make sense? Okay, so I hide this question behind this. Imagine if I do that, okay? That's for number 8. Let's go on. Number 9. For t between 0 to 2 pi, solve cotangent half t equals to negative radical 3. That's tangent t over 2, the reciprocal of the cotangent is tangent, is the reciprocal here. But tangent is negative something when tangent is in quadrant 2 or 4, right? But in quadrant 2 for reference angle 30 degrees, that's 5 pi over 6 plus pi k, which is the period, pi is the period of tangent and cotangent, now multiplied by 2. Okay. Now, when k equals to 0, t equals to 5 pi over 3. But when k equals to 1 is already more than 2 pi. So that's the only answer we have in this number 9. Let's go on. Number 10. For all x in degree, solve. Use sum to product formula first. Okay, so this will be negative 2 sine sum over 2 sine difference over 2 equals to sine x. So negative 2 sine 3x sine x equals to sine x. Okay, negative 2 sine 3x sine x minus sine x equals to 0. Factor negative sine x. So sine x equals to 0, or x equals to 180 degree K, right? 0 degree, 180, 360, and on. Okay, or sine 3x equals to negative 1/2. But that means 3x is in quadrant 3 or quadrant 4. With angles, the reference angle is 30 degrees. But in quadrant 3, that's 210. In quadrant 4, that's 330 degrees. Okay, so the way you imagine is this. Okay, it's 30 degrees, right? Now send it to quadrant 3 and quadrant 4. That's the reference angle here. This is the reference angle. 3x. This is 3x hat. You see? Okay, now of course we are not done yet. We still need to go on further solving for x. Right, so x will be 70 degrees plus 120 degrees K. X equals to 110 degrees plus 120 degrees K. For K, any integer. That's for this number 10. Oh, hold on. Do I have number 11 here? Okay. For t in the first interval, cosine minus sine. Huh? Cosine minus sine. That's cosine sum. Wow. Don't you think that's Mickey Mouse? But trust me, a lot of people leave this blank. Either they don't practice or they don't realize that this has something to do with the product to sum. I mean, this is just the addition formula. This is formula 1, 2. Right? That's formula 1, 2. Anyway, cosine 3x equals to 1/2. So 3x either pi over 3 plus 2 pi k or 5 pi over 3 plus 2 pi k. Now divide by 3. Okay, to help you with your computation to do it faster, well, because we need to get this from 0 to 2 pi, right? Okay, we need to play with the k later on. You may want to do LCD. So this is pi plus 6 pi k over 9. This 5 pi plus 6 pi k over 9. So when k equals to 0, get x equals to pi over 9, x equals to 5 pi over 9. When k equals to 1, it's easier to see. Like the first one, there will be 7 pi over 9. X equals to 11 pi over 9. When k equals to 2, that's x equals to 13 pi over 9. 12 plus 5, 17 pi over 9. Okay. When k equals to 3, it's already outside of 2 pi. So that's where we stop. Number 12, proof from left to right. I think we can go both ways from here, but let's do this from left-hand side. We have tangent and sine, but there is no direct relation between tangent and sine though. Okay, let me write it as sine squared x over cosine squared x minus sine squared x. And then let's do LCD. Sine squared x over cosine squared x minus original sine squared x times cosine squared x over cosine squared x. Once they have LCD, we can put them together. Factor the sine. Sine squared. We get 1 minus cosine squared x over cosine x squared x Okay. Now then I will group this sine squared x over cosine squared x. So this guy becomes this, and this guy becomes this. Is it okay? But that's tangent squared x times sine squared x, which is what we want on the right-hand side. Okay, that's for number 12. Let's see if we have more. Oh, no more. That's it. We are done. Okay, we are done. I somehow think that semester in 419, very likely I gave 5 tests instead of only 4 tests. Let me take a look. Okay, let me take a look. 419. It's possible I give 5 tests that semester instead of only 4. But I need to check though. No, I only give 4 tests. I only give 4 tests. Why am I missing sequence series? Yeah, sequence series, binomial expansion, because those are always in my precalculus. Let me check the final. Yeah, I have binomial expansion in the final. I really don't know what happened on that semester. I really don't know what happened in that semester. Yeah, but in that semester I had these, but I didn't have this even in the final. I didn't have that. So there's a chance it's because, is it because I was really behind for that semester? I just don't have it. I don't know why. I don't know why. I'm pretty sure that I really thought that law of sine, law of cosine sequence series that semester. I have never missed that though. But when I look at the final, let me show you the final. Let me show you the final I gave in fall 19. Very likely at that time, when I look at the final, I just use final from someone else. This is not my final. This is not my final, except the heading, which is mine. Okay, but these are not my final. This is not the way I type my final. Like you see, like the 5 point each, I usually put it here, right? Parentheses. And I don't use one parenthesis for question number 1. I don't use this kind of notation. Yeah, but this was the final, the questions in the final. I use the final from another instructor from SMC, someone I respect. Trust me. Okay. Oh, now I know what happened. So I did cover law of sine, law of cosine sequence series, and she didn't. She didn't cover those. She covered conic section instead. So what happened in the final? I didn't have that. I cut those questions away. But I have binomial expansion. I have binomial expansion. This was the final. So I cut some questions out. Yeah, I cut some questions out because those were not the one I taught in class. A sequence and series, law of sine, law of cosine that we will learn on tomorrow. Tomorrow we'll learn law of sine, law of cosine. And then Tuesday, Thursday, next week, we'll start learning binomial expansion and sequence series. Those are, in my opinion, more important compared to conic sections, which this instructor, whom I took the test from, think more important. Okay, but don't worry about this. Don't worry about this. Okay, I need you to realize that in this last test that we work on, test 4 from my 419, I happen not to include these topics. That's why we can finish the whole test right now. In your test, however, 2 weeks from now, you will have, your test will be even more similar to spring 20 and fall 20. Okay, so get ready with this type of question. Okay. Now, on Monday, we will work on law of sine, law of cosine. Okay. And then Wednesday, we will work on sequence series. So number 10, number 11, and last question here, number 15. Okay. Yeah, that's what we will have on Wednesday next week. Well, anyway, that's for today. See you then on Monday.